Hi physics students, I'm going to walk you through the answer key for Warmup 5-7. This one is conservation of energy, where we've got a slingshot shooting a rock. So in this initial scenario, I'm going to make my system the rock and the slingshot. And in the initial scenario, we've got the slingshot stretched. I know this because it gives me a K value and a stretch distance. So when you have a slingshot like that, you definitely have some elasticity. So I'm going to call it elastic potential energy. So that's elastic. And then once the rock is up in the air, the velocity is 0, it's momentarily stopped. So there's no kinetic energy, but that means that there is all gravitational potential energy. And they have to be the same amount of energy, so 3 blocks on each side. It doesn't matter how many blocks you use as long as they are equal on both sides and that you start with the same initial and final energy. So since they are both equal, I am going to go ahead and set the elastic potential energy equation 1/2 K delta X squared equal to my gravitational potential energy equation. You can only do that if all of the energy in the initial state is equal to all the energy in the final state. If it's split between some kinetic, some gravitational, you cannot use this method. So let me go ahead and plug in my values. K is 100 Newton meters. Delta X is 0.3 squared. Mass is 500, but I need to convert that to kilograms, so 0.5 times 9.8 times height. So let me go ahead and plug all of this into my calculator. 4.5 here on the left side, and 4.9 times h. So I'm going to divide 4.9 to both sides, and I get a height of 0.92 meters. So this next problem is focused on work and power. The first question is asking for work, and we are given a mass and a distance, and our unknown is work. So for solving for work, the equation for work is force times distance. The problem is we don't actually have a force value given to us. We have a mass value and a distance value. So in order to understand what force we're supposed to use, we need to think about the situation. A rope is pulled. We can assume it's pulled at a constant speed, and therefore the force of gravity pulling down on the pail is going to be equal and opposite to the force of the rope pulling the pail up. So the force in which we are pulling is actually equal to the force of Earth, which is mg. Distance in this problem is a height value. So if I plug in h instead of d for that distance, I get mgh, which is our gravitational potential energy equation. If you understand the definition of work, work is the change in energy, and in this case, it is the change in gravitational potential energy. So all we have to do is plug in our values for mass, gravity, and height, and our work is equal to 1,176 joules. Joules is our unit for energy. Since work is the change in energy, it is also the unit for work. Next problem, we are solving for power. Power is equal to work over time. We've got 5 seconds here, and we've got work from part A. So I'm just going to plug in my values, and if I divide this by 5, I end up with 235.2 watts. Watts is our unit for power. It's a unit you see in your electricity bill and a unit you've probably heard of. I like to write it out because the abbreviated version for watts is W, and so is the abbreviated version for work. So write out watts in words and then abbreviate work as W is my recommendation. All right, everyone, good luck on this worksheet. If you have any questions on it, or this warm-up, if you have any questions on it, feel free to contact me.